Okay, so last section in the course. So here we have a compact closed form for the general power series. Okay, where A is the center of the power series. Okay, one thing to note here is that for the n equals 0 term, we let this x minus a to the 0 be 1, even when x is equal to a. Okay, we do this by convention, which means we do it to make our lives a bit easier, to make this closed form make sense and not add a complication. Okay, so now that we have power series, the question that arises is, can we take a function, just any old function, and write it as a power series? So let's write down the question. For which functions f can we write f of x is equal to a power series? Cn x minus a then. Okay, so there's all kinds of questions here. I should emphasize that Cn is a real number. Okay, so the only variable on the right-hand side is the x. So when can we take a function write it as a power series? Okay, when are we going to have equality here? Okay, so for which functions f and for which x values is this going to work? The answer to this question is it's complicated. You're going to take Cal 3, right? So we approach this in Cal 3. For now, what we're going to do is we're going to assume that this works. So in NYB, Cal 2, we're going to assume that this works and then try to find this Cn here. So again, so we're going to, let's, how should we put this? Let's see, let's put a line here. Okay, we'll put a big if here. If f of x is equal to a power series, this isn't always true. I'll give away that much. Let's say it is. Let's find the values Cn for n equals 0, 1, 2, 3, and so on. Okay, so the idea here is to start taking derivatives. Well, okay, so f of x is going to be C0 plus C1 x minus a plus C2 x minus a squared plus c3 x minus a cubed plus dot dot dot. So we're going to start taking derivatives. So f prime of x is, what is f prime of x? C1 plus 2 x minus a. I lost my C2. 2C2 plus 3C3 x minus a squared plus dot 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 dot. So f prime of a, if I plug a in for x, here's the trick. You get just C1 because all these terms go away. They all have a 0, 0. Next, f double prime of x is 2C2 plus let's see here, 3 times 2 C3 x minus a plus dot dot dot. So f double prime of a is equal to 2C2. So let's circle these things. We'll need them later. Okay, let's do one more derivative. So the third derivative, f, let's put a little bracket here. F, the third derivative of x is going to be 3 times 2 times C3 plus terms involving x minus a. So the third derivative with a plugged in is just 3 times 2C2. So this is the one that, what's wrong over there? So we need a 3 there. So this is the one that's going to give us our pattern. C3 is equal to f of 3 with a plugged in divided by 3 times 2. So we're going to write this as f of 3a, and we actually write that as 3 factorial. Now, if you think about it, C4 will be f fourth derivative of a divided by 4 factorial. And in general, Cn will be the nth derivative with a plugged in, all divided by n factorial. So let's write this. So if f of x is say writable as a power series, so this is a big if, right? Okay, I want you to underline that. This is not always true. And we're not even going to prove when it's true in this class. Then, well, here's our formula for the coefficients Cn.